Let's discuss the common data question 50 and 51. The common data for 50 and 51 from test series 4, and the topic is again thermodynamics. A lot of questions from thermodynamics this time. Okay, so a cyclic process is given on a VP diagram as shown. Okay, so this is how the cyclic process looks like. Okay, so and what is asked in the 50th bit is the magnitude of the work done. Okay, so magnitude of the work done. So we know that the work done by the gas is basically the area under the PV diagram. So we can actually find out the area in a VP diagram also, but let's just draw this in how does it look in the same process, how does it look in a PV diagram, because then we can easily answer these two bits. So for that, what I will do is I will make some points, I'll mark some points, and then I'll probably draw that. So this point is A, and this point is B, this point is C at the bottom, and this point is D. So the corresponding points on a PV diagram will look something like this. A is this, B is this, C is this, and D would be this. So this is just, you have to draw how does it look when you draw the same points in a. So remember, at B the pressure was P2, this is a PV diagram, and at D the pressure was P1, whereas at C the pressure was the volume was V1, and at A the volume was V2. So and this arrow is important. How do you draw? So from A to B, if you look this, from A to B the pressure is increasing whereas the volume is decreasing. So in the same way, what I can do is, in the same way, so what is happening is, if you look at this diagram, and from A to B my pressure is increasing, volume is decreasing. So similarly from A to B, volume is decreasing and pressure is increasing. So these arrows, you have to just see relatively what is increasing, what is decreasing, and draw the diagram. So now, so this PV diagram, let me just redraw it again here at the bottom. So it's something like this. Okay, this is V1, this is V2, this is P1, and this is P2. This is my P2. Let me draw the circle correctly. Okay, just let us redraw it again very carefully. Okay, this is V, this is P. Okay, and this is how my circle or the ellipse. See, I haven't said this is a circle. It looks a circle, but it doesn't. I didn't say that this is circle. In general, it's an ellipse. Okay, so this is my V2. And this is my V1, this is my P1, and this is my P2. Okay, so now the area of this, so this is an ellipse, and see, remember, this is not a circle, because nobody said that for a circle this V2 minus its radius have to be same in both. So V2 minus V1 by 2 need not be equal to P2 minus P1 by 2. So that's why it's not a circle. Okay, because in general these two need not be equal. So it's an ellipse generally, and the area of the ellipse is pi AB, where A is basically the major axis and so A I can write V2 minus V1 by 2, and B I can write P2 minus P1 by 2. So area of this ellipse will be pi by 4 P2 minus P1 into V2 minus V1. So the answer for this 50th bit is C. Okay, so now let's look at the 51st bit. Okay, now 51st bit is whether the work is done by the gas, work is done on the gas. Okay, so let's now again come back to this PV diagram. Okay, and mark these points as A, this point as B, and this point as C, and this point as D. So now if I consider A, B, C, okay, and now the process A, B, C, work is done on the gas. This is because of the arrow. Like if you look at the arrow is like this. So what it means is when you're going from A to C through V, you're basically compressing the volume. I mean, you're reducing the volume. So you need to do the work. So work is done on the gas, and that area is basically the area under this entire curve. Okay, so that is WABC. Now look, if you look at the process CDA, so here what is happening is when you go from C to A, volume is increasing, so work is done basically by the gas, or work is done by the system, where the system is the gas. So that is WCDA. So in this case, work is done on the gas, and we know that WABC is more than WCDA. This is just because WCDA will be this area and WABC will be this entire area. Okay, so now WABC is greater than WCDA, so net work is done on the gas. So the answer is B. Thank you.